Now, question number 11. A large heavy box is sliding on a frictionless surface of an inclination of theta from a point P on the bottom of the box. A particle is projected inside the box. The initial speed of the particle with respect to the box is u, and the direction of projection makes an angle of alpha with the bottom of the box as shown in the figure. Then find the distance along the bottom of the box between the points of projection P and Q where the particle lands. Second question. If the horizontal displacement of the particle as seen by an observer on the ground is 0, find the speed of the box with respect to the ground at the instant when particle was projected. So this is the question. So here this is one box. It is moving downward on a smooth inclined plane which is making an angle of theta. So in this box, from P point to Q point, one ball projected like this. So automatically it comes like this. So what is this? This is called range. So for this, what is the angle of projection? Alpha inside the box. He is asking PQ. What is the first one? Range. He is asking first one range. First question. Second question. Outside, one observer is observing this box. That I am assuming that made by glass, because inside what happening, outside observer observing. So when this is projected, so it is moving with some velocity. That velocity what? U. At particular instant velocity u. So what is the velocity? How? When he is observing the ball, it is at rest only. It is not projected. Actually projected only, but appears to outside man. It is at rest only. Ball not projected. Like that, vision creates to this observer. For that, what is the velocity of the box? Instantaneous velocity at particular instant. That we are finding. So here, what we are finding? Velocity of the box. In which case, instantaneous velocity of the box for vision created to the observer, that ball not projected, like that appears outside people. Further, what is the velocity at that particular instant? So before going to this, we are discussing about inclined plane. What is the motion of an object on an inclined plane? That is very important, because here acceleration due to gravity dividing into components. Due to that, we are going to discuss about motion of a body on an inclined plane. For example, this is ground. Here I am taking one body. What is the mass of the body? M. So this is the plane of contact. This is the center of gravity. So mg weight acting downward. Perpendicular to plane of contact, one force exerting, that is called normal reaction. This is called normal reaction. And what is the mg? Weight of the body. What is the mg? Weight of the body. So this is happening. If the body is on the horizontal plane, same plane just bending like this. So what happened? This plane like this inclined theta. Then what happens? Just it came to like this. So automatically what happens here? Now this is the normal reaction. This is the normal reaction. Actual position what? This is the actual normal reaction. This is the actual normal reaction. So this is the initial. This is also normal reaction initial. This is our present normal reaction. So how much angle it is making? This how much we had inclined, that much angle it is making. So here what happens? I am resolving into two components. What I am dividing? Normal reaction resolving into two components. So what happens here? Where it is making theta angle, that is called cos theta component. Where making theta, that is called cos theta. Perpendicular to this automatically sin theta. This is belongs to resolution of vectors of normal reaction. This belongs to resolution of vectors of normal reaction. Okay, this completed. Next I am going to weight. So, what about weight resolution of vectors? Now, for example, this is the object on the inclined plane. This is my center of gravity. So, mg acting downward. mg always acting downward only. So, what is this? This is the initial normal reaction. But present, what is the normal reaction? This is present normal reaction. This how much angle here? Theta. So, automatically this also theta. So, mg making here theta angle. Where making theta angle? That is called cos theta. So, this is called mg cos theta. So, perpendicular to this, what is there? mg sin theta. So, this is according to resolution of vectors. Now, what is the formula for force according to Newton's second law? F equal to ma. What is the formula for force? F equal to ma. You compare that. F equals to ma. That equals to mg cos theta. So, what is the acceleration? G cos theta. So, downward, what is the acceleration? G cos theta. What about this acceleration? Like this, G sin theta. So, acceleration divided into two components. One is G cos theta, another is G sin theta. So, finally, what I am writing? This is G cos theta. This acceleration is G cos theta. This acceleration is G sin theta. This is A. This you take A1, this you take A2. So, like that, acceleration due to gravity dividing on the inclined plane. This also same like that inclined plane. So, in the inclined plane, we are changing the acceleration due to gravity. It's like this. Now, we are going to our problem. Now, for example, I am taking where body moving. Okay, I am taking only acceleration concept. Then what happens once you see? For example, this is one inclined plane. On the inclined plane, one body coming like this with u velocity. How much velocity? U velocity. Now what happens to acceleration resolutions and velocity resolutions of the body? This is making theta angle. So where it is moving? From here moving. Here to here moving. So that you take as x-axis. Automatically perpendicular to this y-axis. That we are taking. So this is my origin. Body where moving like that direction we are taking coordinate system. Now here what happens I had already told. If this is the g, what about this? G cos theta. And what about this? G sin theta. Okay, now give directions. So what happens here? In this direction it is G sin theta. So what about this? This plus only. What about this G cos theta? If this is y-axis, upward y-axis, downward y dash. So minus G cos theta. That is about acceleration due to gravity resolutions with respect to coordinate system. That completed. Again you go to velocity. This is my velocity. Where is the velocity? Velocity is like this. If this is theta, automatically this is theta. This is my velocity. So automatically what happens? Two components. U here making theta component, theta angle. So automatically, what about this? U cos theta. And automatically, what about this? U sin theta. That is resolution of vectors. Now you compare here. U cos theta along the x-axis, so positive. U sin theta downward. Downward means y dash. This x-axis y dash. So what I am taking? Minus. These are the velocity components and these are the acceleration components. Like that we are dividing in the case of motion of a body on an inclined plane. It is coming downward. If you want to find the displacement, s equals to u plus half h square you apply. We are getting. Otherwise v equals to u plus at. For that we are getting final velocity. Again you apply kinematic equations for finding anything. But concept is this only you are applying. If body is coming like this downward. If body moves upward, that also we will discuss. This total concept completes. So, if body moving along an inclined plane, for example, here what happening? Body moving like this, upward, reverse. And already told which direction moving, that you take x. So here I am creating coordinate system. This is x-axis and this is my y-axis. And already told g is like this, mg. What about this? G cos theta. If it is theta angle. What about this? G sin theta. Okay. Okay, now it is moving like this. You take g cos theta, g sin theta components. What about g sin theta? Like this direction. So minus. What about this g cos theta? Downward. If this is x-axis, x dash. Sorry. This is x-axis, this is x dash. And y dash. This is positive. So reverse moving g sin theta. So what happens? Negative. Downward. This is also negative. Both are negative in the case of acceleration due to gravity. When body moving upward. Completed. Next you go to velocity. What are the velocity components? What is this? This is the velocity. Where it is making angle theta? Here making theta angle. Now we divide this. What about this? U cos theta. And what about this? U sin theta. Body are moving along x-axis. Like this one. Positive. How it is? Perpendicular to x-axis. Positive. So in this case, both velocities are positive. Both accelerations are negative. For example, after t time, what is the velocity of the moved body? This smooth inclined plane again, that is important. Again, you apply kinematic equations for finding velocity or displacement or anything. Same question he had given, projected. At that time, what happens? Normal position on the ground, what happens? Same like the formulas only we are applying. For example, I want to find, for example, this only, here projected like this. In that case, what happens? For example, same like this only on the inclined projected. What is the range? He is asking. What is the formula for range? For example, this I am taking alpha angle. What is the formula for range? U square sin 2 theta by g on the horizontal plane. That only you apply. What is the formula range? Generally, U square sin 2 theta by g. Okay. U means what? Initial velocity. He will give what is the initial velocity. Sin 2 theta. So here theta means it is horizontal plane. But here what is oblique plane? How much angle? Alpha. So what I did? U square sin 2 alpha. In the g place components I did. Downward what are the components? G cos theta. Which cos theta? Minus g cos theta. So that is the range. Again minus means plus taking only magnitude. So like that this is alpha. So that is the range. Similarly maximum height we want to find. What is the maximum height in the case of projection? What is the formula for maximum height? U square sin square alpha by 2g. So maximum height U square sin square alpha. This U I am taking, this alpha I am taking. By 2g. 2 into g. What is the g value? Minus g cos theta. That's all. Minus represents what? Just direction only. Again we are taking magnitude plus reference only. So like the concept we are applying. But in the when we are applying minus as it is you write. Sometimes it is useful. What is the according to sign convention? What is it that you write as it is? Finally we are writing only magnitude. So that is the concept of motion of a body on an inclined plane? Is it moving downward or coming downward? Moving upward or coming downward? Again projected. Same like this. Downward projection also we are taking. This is about total explanation belongs to inclined plane. Now this concept in this problem we are applying. Now here what happened? Here he is asking range. It is projected with alpha. This angle theta given. So first what I am finding? Range only asking, range find. What is the formula for range? Directly write. Range equal to what is the formula generally on the oblique projection? U square sine 2 theta by g. So U square sine, here what is the angle? 2 alpha by g. In the g place what writing? Components writing, I have already told. So which direction moving? Body moving like this direction. So this is my x axis and this is my y axis. So automatically what happens? Downward y dash. And what about this? X dash. Which direction body moving? That I am taking x. Like that coordinate system creating. Okay, now tell, if this is the g, two components, theta. What are those? G cos theta, G sin theta. What is the formula for now? Range, G means always downward taking, acceleration due to gravity. What is the formula for range? U square sin 2 theta by G. G means here what I am taking? G cos theta. So that is the range. So in the box when projected from P to Q, what is the distance on reaching the box B to Q is called range. Range is PQ, that is U square sin 2 alpha by G cos theta. Range completed. Okay, again you go to what is asking? One man observing outside. What I had observed? Ball projected only, but it is not visible to him. Ball not projected, like that he is thinking, like that vision created to him. For that purpose, what happens? From here to here, what is the range? That much range, what is equal to range distance this box traveling. At that time what happens? This displacement S1 reverse what? Same S1. S1 minus S1 0 happens. Relative displacement 0. So it appears to rest. Bar not projected like that thinking. Outside people. So for that first what I am taking? Range completed. Again what I am finding? To reach from here to how much time taken? In that time only box moving. So now here to here what is the time? Time of flight. Now we go to time of flight. For finding second thing, I am going to time of flight. So what is the time of flight? Time of flight equals what is the formula? 2u sin theta by g. So 2u here what is the g cos theta? G cos theta means you write downward only, na? It is moving like this upward. G cos theta is minus G cos theta. Sin convention. This is G sin theta. Okay, now at the time of flight 2u sin theta by G. So 2u sin theta means sin alpha by G. G means here what I am taking? G cos theta. Then again minus G cos theta. Time is positive only. At the time consider that things later. So that happens. So this is time of flight. Range came. So what is that range? This is the range. So that I am taking as x. So this box also same distance traveling. X distance traveling with u velocity. Constant velocity at particular instant, not total. So at particular instant, what is the velocity? U. So how much time? This time of flight. So what is the displacement? Velocity to time. By using that concept, we are finding the velocity of the box. So this is displacement equal to range. Time equals to time of flight. Now this concept I am applying now. So by applying that we are getting one equation, or solving that equation we are getting u. What is the u? Velocity of the box. What is the u? Velocity of the box. So that is our question. So for the purpose, okay, now here what I am taking, I am not considering this in this direction moving this only, but I want to explain the projectile motion. Due to that, what I am taking? I am taking this is x-axis because I am considering ball. If you consider box like this one happens, but I am explaining the motion of the ball. No? So which direction ball moving? Like this moving. So you take this is the x direction because we want to explain the motion of the ball. Due to that I am taking. First you take ball. First case ball. In the first case ball are moving like this moving. So this is x-axis in this direction. What about this? Y-axis. That's all. So what happens? U square sin 2 alpha by g cos theta. Correct only. In this case also minus g will come. Correct only. So again what happens? U square sin 2 alpha by minus g cos theta. Correct only. So ball like this moving. Then what happens? This x-axis and this y-axis always coming downward only. No? Downward means minus sign. Correct only. Now next what happening here? Next case, in second case, box moving like this. So in that case, you coordinate system take like this. Second case. In the second case, what is the coordinate system? This is the box moving like this. Like this you take. Okay. So this is the box moving direction, and remain this what about this? This x means this x dash, and what about this y dash? Okay. Now I am applying s equals to ut plus half a t square. In this case, what happens? U value plus happens. You also dividing components and all, but components no need only because with respect to inclined plane only taking. So u means u only because on the inclined plane only taking, not from outside. So u only. But what we are taking here? First what